if you notice on 3, we have two equations like we had before, but what is the difference that you're noticing on these two equations? Anybody? They are inequalities versus equal signs. So what we're going to be doing is we do the exact same thing that we've done before in regards to graphing them, setting up as y equals mx plus b, and then the difference is our solution will be a shaded area, possibly, versus a point or a line, okay? Because now its values are less than or equal to, etc., okay? So a couple things. Let's kind of remind ourselves on inequalities. When you graph an inequality, you have four signs you can see. You have a greater than or a less than, a greater than or equal to, or a less than or equal to. Okay? When you have a greater than or less than, you are going to draw your line like this with little dots or dashes, whichever way you like better. Okay? When you have a greater than or equal to or less than or equal to, you will actually have a solid line. And the reason that is this solid line is stating that it's equal to, so those values hold true. On the dotted line or dashed line, it's saying that those actual values on that line are not part of the solution. Okay? Does that make sense? Okay. So we actually are just going to graph these lines like we would a normal equation. I say graph it as if it's equal to, and then you use your inequality then and apply it at that point. So I would graph this as like x equals 5. Okay? So where is x equals 5? Go over to where it's 5. 1, 2, 3, 4, 5. Yep, straight line up and down. Because it's greater than or equal to, it will be a solid line. There you go. Hopefully yours is a lot straighter than that, because that's a really bad straight line. Okay, so now then you have to look at the inequality sign. So what it is saying is the solutions to this function is that x is greater than or equal to 5. So you look at where x is 5, like where it hits the x-axis, and you ask yourself, where is x greater than that value? To the left or to the right? To the right. So then you shade everything that holds true. So if it's greater than or equal to, all the values to the right of this line make that solution to that line or that equation. Okay? Don't do it real heavily. Just do a nice little light graph or shading, because you'll see why in a second. Okay? Then we get to the next one. So I like to put these in y equals mx plus b. So I'm going to say y is less than or equal to negative x plus 3. Okay? So I have 0, 3 is my b. 1, 2, 3. There's my y-intercept. And then my slope is negative 1. So I go down 1, over 1, down 1, over 1, etc. And I'm just going to do that. And I'm going to draw a line and connect them. And because it is less than or equal to, it is a solid line. Okay. So now we have to look at the graph, and it says, okay, y is less than or equal to these solutions. So when I look at my line, which is the solutions, because it's saying y is less than, I go to where the y-axis is and I find the y point, and I say, okay, y is less than that point. So where is y less than this point? Above or below? Below. So therefore all my solutions are going to fall down. They're going to be below this line. Okay? Now if you notice, I'm getting to the point where my shading is overlapping. So up here it's not, but when I get down here in this area, notice how it's shaded by both lines, or both functions. Therefore, this shaded part is actually the solution to these two equations. Meaning, any number, any x value within this shaded area, if I plug into either one of these equations, they would be true. So this is my solution that makes both of these true. Okay, so my solution is not a point this time, but a shaded area. Okay? Alright, questions on that? Alright, let's look at number 2. Alright, let's go ahead. The first thing I want you guys to do is look at the very first one here, and let's put it in y equals mx plus b format. Let's remind ourselves the rules of inequalities. When you have like a negative 5y and you need to divide by a negative, what do you do with the sign? You have to flip the sign. So remember that still holds true. So go ahead and put these in y equals mx plus b. And then let's just do the first one and graph it, and then we'll talk about the shading in just a sec. Okay? So, in looking at these two equations, first of all, what I didn't mention on this first one here is it says is 5, -2 a solution. So basically what it's saying is if I input 5 into either of those, will that actually be true? So basically what it's saying is 5 greater than or equal to 5 for the first one, and that is yes. Okay? And then if I put 5 in the other one, so let's do what's that? Right, so you plug in the 5 and -2, so on the equation it's going to be 5 plus a -2, is that less than or equal to 3? And that is, so therefore that is yes, so therefore it's a solution, okay?
So when you plug it into the two different ones, if it's like not one of them, if it's like yes and a no, would it not be?
Then it's not a solution, yes. So if I do, so basically let's say I did 5 and -2 and it was no to the second one, therefore this is not a solution. It means it probably falls into this area, but not this area. If it's yes to this one and no to that one, means it falls into this area, not that area. Okay? When it's yes, it means it falls into the shaded area.
How did you plug it in again?
I just took the value, this is the x value and that's the y value, and I plugged them into each one of these equations. So I did, since there's no y, I just did the x value for the first one. And so I put in 5 for x, and then it's greater than 5, and that is true, so therefore it's yes. On the second one, it's x plus y, so I did 5 plus a -2 using the x and y values there. And then that is less than or equal to 3, so that is yes. Okay? If it was, let's say, 7, 2, then it would be yes for the first one, but it would be no for the second one, because it would be 7 minus 2, which is 5. That is not less than or equal to 3, so therefore that's a no, so therefore that would not, 7, 2 is not a solution for either of those.
Okay.
Okay? Alright, so then I'm going to do the y equals mx plus b. I get 5y equals -4x minus 20, so y equals -4/5 x minus 4. Because it is, I did not divide by negative, I keep the sign, so it's actually a greater than, okay? So my line will be dotted when I graph it. So I'm going to go 0, -4, and then I'm going to go down 4 over 5. Okay, it's a dotted line because it is not an equal to. Okay, so when I do that, it says it's greater than. So I want to find where y is on my graph, and I say, where is y greater than that value, above or below? Above. So therefore, this is going to be my shaded area of that line. Okay, that means anything in this area is a solution for this. Okay. Then I look at the next one. I'm going to get 5y equals -4x plus 10. So I get -4/5 x plus 2. Notice how I have the same slope. Therefore, what do we know about them?
Parallel.
They are parallel, okay? But because it is a greater than or equal to type situation or inequality situation, you actually could have solutions. So because it is greater than, so it's going to be y is greater than that value. So I'll go 0, 2. I go, again, down 4 over 5. Okay? It is not an equal to, so I have a dotted line again. Okay? Now this one is saying it's greater than, so finding the y on the axis, I ask myself, is y greater above or below? It is above, so therefore, if I shade there, and so you can see where they overlap in shading, then is all above this line here. So basically, any value that is above this line would be true for both situations. Okay? Does that make sense? Okay. Alright, so, and what this next part is asking me, it said, what would be the solution to? And what it's asking me is, in between these two lines here, is there a solution? And there's not, because there's not a point within these two lines that is true for both. So therefore, between these two lines, there is no solution. Okay, but above this line, it is all those. Okay, And what I mean by solution, again, is just remind you guys, is the values that would make both those equations true. So basically, if I plug in a value, so let's take, let's see, what is this one? Let's take like 5, 0. So if I take 5, 0 and plug it into both those equations, that would be true. So if I do 4 times 5 plus 5 times 0, is that greater than negative 20? Well, 20 is greater than negative 20, so that is true. If I do 4 times 5 plus 5 times 0, is that greater than 10? And that is true. So both of those are true, therefore that's a solution. Okay? Alright. Now the next one I want to look at is 3. Alright, so let's graph 3 together. Y is less than or equal to 7. So we go to where y is 7. And then, is it a solid line or a dotted line? It is solid, so go ahead and do it. All the way across. Okay. So now, it asks, is less than or equal to 7. So I go to where it is on the y-axis, and I say, where is y value less than or equal to this line? Is it above it or below it? It is below, so I do a nice little shading here. Right? Then, now I'm going to go to my absolute value. Okay, so this is from last unit in absolute value. It is the V1. So when you have your absolute value, again, how many lines you're going to have? Again, you have your 2 lines. So we need to know A, we need to know H, and we need to know K. So what is A? It is negative 1, because that's your value in front of the absolute value. What is your H? Negative 3, because that's the value inside, but opposite, right? And then what is K? So therefore, what is my vertex? Negative 3, comma 2. Okay, so let's go to negative 3. And then let's go 2. Okay, that's going to be your vertex. And then we use our A value for our slope. So down 1 over 1, down 1 over 1. And then we have to do it from the other side. Okay. So questions on graphing that one? Okay, so now that we have it graphed, it's saying that it is greater than. Okay, so now that it's greater than, what do I need to do with this line that I just drew? It should be dashed. Okay. Alright. Because it's not an equal to, so it's dashed. Alright, so now it says it's greater than. So if I go to kind of where the y value is, and I say it has to be greater than. So is it greater than above or below this line? Where's y greater than? Above or below the line? It is above. So therefore, that's going to be everything this way. So then where am I overlapping? I'm overlapping below this line, but above this one. So my solution falls within this line here, and then between that line there. That is the solution. Okay, so that's the solution, where all points inside that area would make both of those true at the same time. Okay? Alright, so I'm going to have you guys try number 4 on your own. Try number 4 on your own, see what you guys get. So just very quickly on these, you guys, you're going to have as follows. You're going to have negative y is going to be less than or equal to negative x plus 7. I'm going to divide by negative 1, so what happens to my sign? It flips. So it's going to be x minus 7. So again, I have 0 comma negative 7 as my b, and my slope is 1. Okay? Then I have the next one. I'm going to have y is going to be less than negative x plus 7. My starting point is 0 comma 7, and my slope is negative 1. And then I just have x is greater than 2. So x is greater than 2 is going to go here. It's a dotted line because it's not equal to. It's greater than, so x is greater to the right. So this is my shading here. Then I have 0, negative 7. And then I'm going to go up 1 over 1, up 1 over 1. So this is kind of the line like that. It is a greater than or equal to, so it's solid. And it's greater than, so y is greater above it. Y gets bigger this way, so this is going to be my shading this way. Okay? And then I have where y is less than, so I go 0, 7. And then I'm going to go down 1 over 1, down 1 over 1. So I connect it this way, and it's a less than, so it's not, it's a dotted line. Okay? And so I have, that is going to be, it's less than, so y is less than this line going down, so this is the shade this way. And then where the 3 actually intersect is all right in here, so this is your solution. So what I need to see, or what you're going to need to make sure you show when you actually do these, is number 1, that your lines are dotted or dashed or solid appropriately, and then that's the common area between the 3 or 2, whichever one you're doing. Okay, so that's the solution that makes all that true. Okay? Alright, so today we looked at 2 things. We looked at how to graph, how to find a solution, like what does it mean to find a solution? Okay, plugging in the values for x and seeing if the y value is what you're looking for. If it equals, it is yes. If it does not, it is no. Then we actually found it by graphing the 2 and where they intersect. That is the solution for both. If, however, though, you have 3 conditions. You have where it intersects once, that is one solution. You have it where the lines are the same, that's infinite many solutions. And then you have it where they're parallel and they don't intersect, that is no solution. And that is when your graphs or your functions are equal to. But then we moved on to inequalities, and when you move on to inequalities, your solutions then are the shaded areas. You have to say if it's less than or equal to or greater than whatever, find those values and shade then where that makes it true. And then where they overlap is the common area, that is the solution for those 2 functions then. Okay? If they don't ever overlap, let's say these 2 lines here, this one went down and that one went up. If they don't overlap, there is no solution. So if there's no overlap, there's no solution. That's the one thing you want to make sure you realize. Okay?